All right, we're gonna be moving on and finish the section 14.7. So last time we talked about this example, but we haven't finished it. Just a little bit about this one. So today we're gonna work it out. Step one. Usually you want to sketch out the domain though, so you can see what is going on here. I'm gonna sketch D. Okay. Oh, circle. Yeah, that look good. Just have to redo this thing here. -1, 1. Right? On the boundary, so we have a x squared plus y squared equal 1. On the inside, x squared plus y squared less than 1. So step one is that we're gonna find all the critical point inside the region. Fx equal to set x squared set equal to 0. Right? And then we have fy is equal to 4y to the 3 set equal to 0. So we have x equal to 0, y is equal to 0. Well, it looks like that is it, right? It's only one critical point here, right? Critical point. 0, 0. Okay, make sure you pay attention to this critical point because we're gonna come back to them in the very last step. So step 2. Okay, we're gonna find all extreme value or point. I'm gonna call extreme points there, not extreme value. Either way. On the boundary of D, so on sub y squared equal 1 minus x squared into fxy gx there. 2x to the 3 plus y square. Oh, actually, you can know this, but it's y to the 4 just y square. So I'm gonna 1 minus x square. Yeah. Okay. So 2x to the 3 plus 1 minus 2x square plus x to the 4th. And this one would be I would arrange this one x to the 4 plus 2x to the 3 minus 2x square plus 1. Okay. Well, where x is between -1 and 1, right? You have an endpoint x equal -1, y equal to 0. Right? -1, 0. And then the other endpoint is going to be x equal 1. At x equal 1, y equal to 0. To find the critical point of gx, that is going to be using a derivative, right? So g prime x equal to 4x to the 3 plus 6x squared minus 4x equal to 0. Oh man, I don't have to run through the rational root theorem. Yeah. Well, 2x squared plus 3x minus 2 equal to 0. And then we have a x, this is the 2x minus 1, x plus 2 equal to 0. And then from here you see that x equals 0, right? X equal 1 over 2, x equal negative 2, right? Remember, we only take x equals 0 and x equal 1 over 2 because x equal negative 2 is not in the domain. Use y squared equal 1 minus x squared. Use the boundary to find y. The boundary circle to find y. At x equal to 0. So y squared is going to be 1 minus 0 square. Meaning that y squared is equal 1 and y is equal to plus or minus 1. So that means from here we have two critical points. The critical point zero, 1, 0, negative 1. Okay. At x equal to 1 over 2. Y squared is 1 minus 1 over 2 square. So y squared is 3, 4. Right? Meaning that y is going to be a plus or minus root 3 over 2. Right? So we have the two more critical point. One over 2, root 3 over 2, 1 over 2, negative root 3 over 2. In step 3, just find the output. Right? Of all critical points and extreme point. And compare. Yeah. One of them is going to give you the max, the other one is going to give you the min. So I'm going to write them all out. 0, 0, f of negative 1, 0, f of 1, 0, f of 0, 1, f of 0, negative 1, f of 1 over 2, root 3 over 2, f of 1 over 2, negative root 3 over 2. Yeah. So if you sub it in, and fx was not that bad though. So make sure you sub it in here. I'm gonna write fxy here again. 2x to the 3 plus y to the 4. Sub it in, we're gonna get a this has to be the absolute mean. And this one is the absolute max. Come on, another example. Find the dimension of the box. What volume? (1,000 cubic centimeter) that has minimal surface area. Well, remember the box there is gonna be x, y, z. Huh? So when you draw the box, it's gonna be x, y, z. XYZ box there. Okay. So from here, you get two things here. You get a surface. Right? According to this one, it looked like that we have to minimize the surface there. Minimize surface area. Well, with the 2xy plus 2xz plus 2yz. And then we have a constraint. The constraint is the volume, right? Now, do 1000 is XYZ. Yeah? So step one, use constraint equation. To reduce the number of variable in the objective function. Function or equation. Okay. Well, you can solve for z here, right? Because usually the surface in terms of x and y, so it's better to keep it that way. Yeah? So 1000 is equal x, y, z. So that means z is 1000 over x, y. And then we're going to sub z into surface area. Okay. S gonna be 2xy plus 2x, right? 1000 over xy plus 2y, 1000 over xy. Right? Okay, so once we finish the sub, yeah, we have a function of two variables. From there, we can figure out the points in which it has a local minimum, a local maximum, right? And if you guys remember in calculus that if there's only one local min or local max for the entire function, then that local min and local max has to be the absolute min or the absolute max, right? If a function has only one local min or local max, then that local min or local max is the absolute min or max respectively. To find the critical point, find our critical point of s x y, and say s is the function in terms of x and y now. Do sx, that partial derivative with respect to x, and be 2y and oh man, 2000 over Okay, man, one of them is going to cancel. Oh, I should have simplified this thing, make my life easier to see here. 2xy plus 2000 over y plus 2000 over x. Okay, so 2y minus 2000 over x squared. Okay, so we have set it equal to 0, right? We have 1, and we also have sy 2x, right? Minus 2000 over y squared equal to 0. Okay, so we have two equations, two unknown. It should be able to solve for x and y. Yeah. Okay, so here come 2y is the 2000 over x squared, right? So here y is 1000 over x squared. So y equal 1000 over x squared. Okay, so we have 2x minus 2000 over 1000 over x squared is equal to 0. Okay, so 2x, right, minus, okay, so oh, man, there's x to the 4th to 1000 x minus x to the 4 equal to 0. Save my life here. X, right? 1000 minus x to the 3 equal to 0. And then we have x equal to 0, right? 1000 minus x to the 3 equal to 0. So x equal 10. Well, x cannot equal to 0, so x equal 10 here. There is only one value. Oh man, how lucky, you know. If it only has one local min and local max, that is the absolute min and max, right? But we only have one critical value, so it has to be the answer that we're looking for. Okay, so when x equal 10, right? I'm gonna sub x equal 10 here. Right? And then y is gonna be 1000 over 10 square, which is 10. So we have x equal 10, y equal 10, figure out z. Right? Thus dimension is 10 by 10 by 10. Another problem here. We're gonna discuss this one. Discuss the following problem. In terms of finding extreme points. Remember extreme point, right? Not to solve it though. fxy equal xy minus 8x minus y squared plus 12y plus 160 given The region D is the center point xy in which 0 less than equal to x less than equal to 15, 0 less than equal y less than equal to 15 minus y. So we have this surface there. Right? Well, remember extreme points, they are the points that is on the boundary. Critical points and end points on the boundary. What are we going to do here? 0 to 15, right? Y is equal 0 to 15 minus y. So when x equal 15, y is equal to 0. And x equals 0, y is equal 15. Oh my God. Okay. Man, I cannot draw a straight line. Okay, it's the straight line here. Okay. Okay, so we have a region that's inside. So this is the region D right here. Yeah. Everything is in here, including the boundary. A triangular region has 3 lines, and there are end points on each line. There are critical points and end points on each line, meaning that you have to repeat finding extreme value 3 times, right? You got to repeat the step 2 3 times. 1 time for the line. Okay, first line, right? X equal to 0. And then remember, for the line x equal to 0, the value of y only go from 0 to 15, where 1 time for the line y equal to 0. Okay, so that is x equals 0, right? I'm gonna do a different color here. So you see that is y equal to 0 here. And then where 0 less than x less than equal to 15. And you got to be careful here. And then you have to do 1 time for the line y equal 15 minus x. Right? Where, well, because you do the substitution, this one, so it has to be x there. Right? X can only go from 0 to 15. As you can see, that is long and tedious. Right? So that is why we have another section that can help us to overcome this long and tedious work. Right? The next section us to overcome this horseshit. Well, so for now, you got to do the long way though. Once you see the next section, you can figure the shortcut on how to find the extreme point a little faster.